Hello, everyone. I'm very excited to be here. Today, we'll talk about distributing data governance, how Unity Catalog allows for a collaborative approach, or how Akamai adopted Unity Catalog. My name is Gilad Asulin. I'm a senior big data team leader at Akamai. With me is Pulkit, who is a senior big data team, who is a senior solution architect at Databricks in the past 2 years, working with numerous of customers to build their Lakehouse. In this session, you will learn about the benefits of using Unity Catalog for Databricks users. I will also talk about Akamai's journey so you can derive the steps you should do to start your company's journey. I will show you what utilities you can build by using Unity Catalog's metadata that can assist you to govern your Lakehouse. But first, a quick intro to Akamai. Akamai was founded in 1998 as a content delivery network company, and till today, Akamai is the lead solution in this market. Akamai has more than 4,000 locations in 134 countries and roughly 800 cities all across the world. We are proud to say that more than 30% of the internet web traffic are passing through Akamai's network. 10 years ago, Akamai started offering its customers security solutions that are based on the content we sell through our network. And last year, Akamai became a cloud provider after Linode acquisition. Application security is the division I'm working in. Every day, we analyze more than 650 terabytes that contains about 120 billion of suspicious events that coming from our customers' data. Our Lakehouse contains several layers. The platform layer enables us to automate and to govern the Lakehouse. The data layer contains all the raw data and the aggregated data of the application security division. We do batch processing and streaming processing, enrich and analyze the data, and then consume it in our data applications and data warehouse. 2 years ago, Akamai started using Databricks, and since then, more than 50 exabytes of data have been processed in Databricks. We have hundreds of tables that contains petabytes of data. In roughly 80 Databricks workspaces that hundreds of engineers are working on. So why do we need Unity Catalog? Using Databricks Workspace eliminates the need to manage and maintain our clusters. But we had some problems with Databricks Workspace's behavior. Prior to Unity Catalog, the ability to share managed tables across workspaces was impossible. For those who are not familiar with Databricks, managed tables are tables that are fully managed in Databricks and similar to tables in relational database. An optional approach was to create an external table for each table we want to share. External tables are tables that point to an existing data source that's stored outside Databricks. Databricks has a limited control on those tables. The way to do that is to create a mount point for each shared table on each workspace. This caused a lot of code duplication, and in addition, mount points are unsecure and unreliable. We encountered another problem related to the inability to restrict user permissions to data at a workspace level. An optional approach to solve this is to create a separate workspace. But this approach leads to the data sharing problem I mentioned before. The last challenge was that Databricks Workspace has a standalone user management system without any relationship with Azure Active Directory. This caused a duplicate user management for each workspace with no ability to govern user access control. Now, I will hand it over to Pulkit to explain about Unity Catalog.
Thanks so much, Gilad. So Gilad explored the impressive scale at which Akamai's application security organization leverages Databricks. He also covered the team's data governance challenges while supporting 80 engineers working in over 80 workspaces and processing exabytes of data. In the next few minutes, I'll walk through a brief introduction of Unity Catalog, and we'll delve into the specific features that address the challenges Gilad and team at Akamai faced. And I'll also cover some additional capabilities Unity Catalog has to offer to empower data governance in a decentralized and distributed manner. Let's begin. So what is Unity Catalog? Unity Catalog is the foundational layer of the Databricks Lakehouse platform. It is the data governance framework that simplifies administration, powers strong governance for your data and AI assets in the Lakehouse, and also facilitates data sharing. It improves productivity amongst all of your users of the Lakehouse. Let's take a deeper look at what makes Unity Catalog's components. So Databricks Unity Catalog represents a shift in how we handle our data within Databricks Lakehouse. Unity Catalog metastores are available across multiple workspaces, centralizing metadata management and enabling users to share data assets across workspaces. User management is now at the account level as opposed to the workspace level, and single sign-on and Azure Active Directory integration needs to be done only once, regardless of the number of workspaces you have. Audit logs are better defined and captured at the account level, and Unity Catalog also offers improvements with the Data Explorer UI and introduces automated runtime lineage capturing within the tool itself. The key concept to note here is of a Unity Catalog metastore, which is different than a Hive metastore. In Unity Catalog, the metastore serves as the top-level container for objects such as credentials, ACLs, catalogs, databases, tables, and so on. Within Unity Catalog, you also get the ability to store and access storage credentials and external locations. These can be shared across multiple workspaces as opposed to storing them on the cluster level or directly on the user principal. It is worth double-clicking on this capability. So as mentioned, Unity Catalog introduces two new account-level objects, external locations and their associated storage credentials. These are objects that are typically defined once with minimal ongoing maintenance. For example, in Azure, a Unity Catalog storage credential is going to be linked to an Azure managed identity, and these managed identities are responsible for assuming the role on behalf of the users or the service principal. This implementation eliminates various administrative challenges that come with rotating storage keys, utilizing key vault, managing secret scopes, and configuring these settings on the Spark cluster. Additionally, it enhances the security by adopting a closed, least privilege access mode from Unity Catalog clusters and SQL warehouses. Let's now compare what has changed in the environment with and without Unity Catalog. So typically, we see customers have different workspaces for development, staging, and production, and each workspace operates with its own Hive metastore and its own user management system. Although table access controls could be configured within each workspace, administrating these settings is a challenge. For instance, if you have to access production data in the staging environment, as you heard Gilad say, you have to go through the tedious process of copying that data between workspaces. And even though an external Hive metastore option was available, it presented challenges for auditing and managing access. With Unity Catalog, the metastore, user management, and access control functions have been relocated to the Databricks account level. This shift makes data access management much simpler, regardless of the number of workspaces you have, because you have to do it only once for any number of workspaces. It is critical to note at this point that a Unity Catalog metastore is at the region level. What that means? That means that you won't create separate metastores for dev or production in a specific cloud region. Instead, you will create one metastore when you're creating on the account level, and Databricks will take care of managing it for you in that region you're utilizing the service. Next, let's look at what the user experience is while running a query with and without Unity Catalog. So again, starting with the life of a query without Unity Catalog. It begins with a user initiating the query or action, which can be submitted in any supported language. This query is directed to a warehouse or a cluster. The table ACLs defined within the metastore of the workspace are checked for grants. The cluster then gets the location of the table from the Hive metastore. The cluster is set up with credential pass-throughs or appropriate instance profiles if you're in AWS, which are used to access the data from the cloud storage. Data is returned back to the cluster, and then the data is filtered based on the actual query submitted, and results are returned back to the user. There are a few things wrong with this flow. The admin in this scenario has to create a lot of setup. First, they have to create separate service accounts. They have to configure secrets. They have to mount cloud locations into Databricks. And they have to do this for every workspace and every cluster within their environment. And second, using credential pass-throughs on a cluster made it impossible for fine-grained access controls, as clusters could be shared amongst multiple users. Now let's just run through what a life of a query is with Unity Catalog. So much like before, a user submits a query or an action in any of the supported languages. It does hit the warehouse or the cluster. The first thing that Unity Catalog enabled cluster would do is hit Unity Catalog's control plane service to check the namespace, metadata, and evaluate the grants for that user. Unity Catalog will then either pass or fail the request the user has made. An appropriate audit log record is generated and written out. In the event the user does have access to the objects requested, Unity Catalog will assume the underlying credentials that were saved by the admin and generate a short-lived token. The token is then shared back with the cluster. And it's important to note here that step 2, 3, and 4 here are control plane activities and are performed within milliseconds. So there's no latency on the user side. Once the cluster or the warehouse has those tokens, it'll go grab the data directly from cloud storage, and Unity Catalog won't be in the path. The data is returned back to the cluster. The cluster does last mile row level filtering and column level filtering, and the results are sent back to the user. So let's look at the benefits of this flow. So one, the admin in the setup only created the IAM role or the Azure managed identity once while setting up the metastore in the cloud region. They created the external location once and the associated storage credentials once, and they set up the access control policies within Unity Catalog. You no longer need to use any of the instance profiles or mount buckets. Neither do you have to work with secrets and Spark config settings on the cluster level. Unity Catalog takes care of authorizing the data access to the user by applying the access control policies the admin has set up within Unity Catalog. This greatly minimizes the operational overhead to govern data within your environment. You're doing all of these steps only once, and it is percolating to all of the workspaces within your environment. The last thing that I want you guys to consider while migrating to Unity Catalog is the notion of user access mode. So with Unity Catalog enabled clusters, when you're creating a cluster, you get an option to pick the user access mode for that cluster. We have a few options. So the first option for all-purpose clusters is user isolation mode. This mode is for general purpose ETL or data engineering, data exploration, and is primarily for SQL or Python users. The user isolation mode allows you to have clusters that are shared amongst multiple users, creating a collaborative environment. However, you can only run SQL and Python code seamlessly within these clusters. Moving on, the second option is that of an all-purpose cluster with single user access mode. The single user access mode is ideal for users who need advanced data science capabilities. It is important to note that in the single user access mode, only the owners of the cluster can execute code, and co-workers can still view the notebook and still collaborate with knowledge sharing. However, they cannot execute code, maintaining the integrity of and security of the code base as well as the data. And last is SQL warehouses. So SQL warehouses are purpose-built for business analysts, for an easy compute, for analyzing data effectively, either with the Databricks provided SQL editor or through popular BI tools like Power BI and Tableau. SQL warehouses are enabled for Unity Catalog by default, and there's no additional configuration needed specifically needed for Unity Catalog. All right. So now with that, I'll hand it back to Gilad to talk about how Akamai team worked through the process of migrating to Unity Catalog.
Thank you, Pulkit. After we understand that Unity Catalog can help us to solve the challenges that we had, we started to collect requirements. The first thing that we needed to take into consideration was catalog structure. What is the best structure for our division? Should it be by environment, or maybe because we have several products, should it be by product? And how will this decision affect the cost? Then we needed to think about my team's role. How is it going to impact our day-to-day work? Yeah. We do want to do a proper governance, but we don't want to be a bottleneck. And how will it impact the interaction with our stakeholders? And how can we minimize the administrative burden so we will keep focusing on innovation and on engineering work? The last thing that we took into consideration was data location. Where should we store the data? Managed tables, or external tables? In case we use managed tables, how can we isolate the production data from non-production data? And how can we differentiate between each product's data? First, we needed to decide how to structure our catalogs. Our teams are segregated by products. The decision was that each product will be represented by catalog, and each environment will be represented by a schema. Then we needed to establish a data governance model, considering that product owners have the responsibility for their respective data, and the need to simplify our day-to-day operations. As a result, we made a decision to apply a distributed data governance approach by assigning the responsibility of data access control to product owners. They have the authority to grant permissions for their respective data. Then we had to make a decision regarding data location. Since most of our data comes from external sources, we needed to create external tables. To achieve this, we choose to utilize managed identities instead of service principals. Managed identities offer several benefits, including automatic key rotation and full protection by Azure. Furthermore, it was necessary to store the data based on its respective product and environment. To address this requirement, we utilized the managed location feature during the creation of catalogs and schema. As you can see here, we created an external location that points to the storage within the product's resource group. Then, during catalog creation, we selected the external location. By doing so, the managed tables are stored in the external location we specified, rather than in the meta store. We followed the same process when creating a schema to represent an environment. The requirement for a data engineering team include ownership of all shared data sources, while a high level of governance needs to be applied to products' data. In addition, we needed to enable stakeholders to have access to metadata. The decision driven from these requirements were that we should create a catalog that contains all the shared data, in addition to the catalogs that we created for each product. then create utility to expose the metadata, and to create dashboards and alert to provide high-level perspective. To make it happen, all the product team need to be engaged in this effort. The requirements was to map all the possible impact on stakeholders, and the decision was to document all the scenarios that can impact the roles in the organization and actively engage stakeholders through communications. According to our decision to apply a high-level governance, we built reports and dashboards to achieve this goal. For that, we used system catalog that contains Unity Catalogs metadata and activities. System catalog has a few schemas. Information schema contains all the metadata information for objects across all catalogs in the metastore. Access schema contains all the activities in the account, such as audit logs and lineage logs. And billing schema contains billing logs. The first utility we built was Catalogs as PDF. This utility was built to expand data assets visibility for non-Unity Catalogs users. For example, product managers. It enables them to comprehend a data potential and support them in driving innovative solutions. Then we build the State of the Lakehouse dashboard. This dashboard helps us to monitor our Lakehouse in several aspects, like cost trends and user statistics. For example, in the cluster type pie chart, we can see what are the cluster we are using. Let's say we want to encourage using serverless endpoints. With this pie chart, you can easily see if it's happened. We can also actively alert the relevant stakeholders if needed. For example, by using machine types a pie chart, for cost reasons, you can notify your operation team when there are clusters using non-reserved instances. Users activity monitor dashboard help us to find abnormal user activities in our Lakehouse. With the user privileges report, we can focus on a specific user and see his privileges all across the Lakehouse. Now, let's put all the pieces together, and I will walk you through the steps needed to adopt Unity Catalog. We can split the migration process into 3 parts. The first part involves a one-time setup at the account level, in which we define the identity federation to synchronize with Azure Active Directory, then create account groups similar to what we did with product owners groups, and develop account-level dashboards as we shown in previous slides. The second part needed to be done for each region. Create a metastore, assign the metastore to workspaces that need to migrate to this region. You can create also a common data catalog like we did, and create metastore level utilities using information schema. The third part needs to be done for each product. Create catalog that represent the product, create schema that represent the environment, set the catalog owner to the product owner that we created before, and for each associated workspace, you need to migrate Hive metastore data. Then migrate the jobs, notebooks to work with Unity catalog tables, and migrate the cluster to support Unity catalog. After we do that, we can revoke the mount points that no longer needed. Here are some insights that can assist you on your journey. Investing in requirements collection early can help you to avoid unnecessary rework. Automating tasks saves time and improves process efficiency. Stay updated on new features, such as serverless endpoints, which can accelerate your work and potentially save cost. And audit logs and billing logs to create dashboards, reports, as we demonstrated before. Based on our experience, Unity Catalog performs optimally when utilizing the Delta Lake format. So let's summarize what we have learned today. Unity Catalog is essential because it has a central access management. You can share data between workspaces easily, and it provides enhanced security. To start your journey, you should collect requirements, drive design decision from the collected requirements, and follow the migration journey slide and do adjustments for your use case. Finally, to build Unity Catalog, to build utilities using Unity Catalog metadata, it is necessary to use system catalog data. During our presentation, we show some utilities and dashboards. The catalogs as PDF, state of the Lakehouse dashboard, users' production activity, and user privileges report. Thank you for joining us today. I hope it will assist you to start your company's journey to adopt Unity Catalog.